Hello students, this is lesson U5A07b. By the end of the lesson, you should be able to say I can apply co-trig function relationships. So this lesson is going to be an introduction to something called trigonometric identities, okay? And when you hear the word an identity, it's something that really defines something, right? So when you look at your ID card, right? That really states who you are, okay? Like what your physical traits are, and perhaps maybe what your birthday is, okay? Some information about you. So when we talk about identities in mathematics, okay, something similar to that effect is also true. So let's take a look at what kinds of identifying features, okay, we can call out on trig ratios. So let's take a look. So I have this set up right now. Okay, this is a 30, 60, 90 triangle, as you can tell from the ratios of sides that we have in place here. Okay, so what I'm going to ask you to do, pause the video for a moment and figure out what is the ratio of sine theta, what is the ratio of sine alpha. Okay, this is a Greek symbol that I have not introduced yet in my lesson series. Okay, and so this is actually yet another Greek symbol, and we call this alpha. So again, this symbol here is alpha. So don't be afraid of this, okay? This is just like the letter X, like the letter Y, okay? This just represents an angle measure in this case, okay? So pause the video to find out what is sine of theta, what is sine of alpha, cosine of alpha, and cosine of theta. Go ahead. So hopefully you guys had some time to think about this. Sine theta is simply equal to 1/2. Cosine of alpha is also equal to 1/2. Sine of alpha is radical 3 over 2. Cosine of theta is also radical 3 over 2. And if you look at this, okay, theta actually is supposed to equal to 30 degrees, and alpha is also supposed to equal to 60 degrees. I want you to look at this very closely, okay? Do you think it's a coincidence that the sine and cosine values are the same for the two different angles? Look at this and look at it carefully and try to think about this. Is it a coincidence that these sine and cosine values end up being the same? Is it a coincidence that these sine and cosine values ended up being the same? If you're thinking it's not a coincidence, you're absolutely right, because this is going to be true for a lot of other instances as well. Okay, you're going to see sine and cosine values being the same for different values of alpha and theta. And what exactly do you think is going to be the thing that's going to connect sine and cosine together? Well, it's the fact that theta and alpha add up to be complementary. They're complements of one another, 30 and 60. So let's take a look at another example where this is also true. So now I have another triangle, and this time it's not that obvious of what theta and alpha is, okay? But we're gonna, do this again. Pause the video to see if you can figure out what this is. Hopefully you guys had some time to think about this. So sine of theta is supposed to equal to 3/5. Cosine of alpha, no surprise, 3/5. Sine alpha, 4/5. Cosine of theta, again, 4/5. What exactly is theta equal to? Well, we can solve for theta in two different ways, right? We can solve for theta using the arc sine function. We can also solve for theta using the arc cosine function. We're actually going to do both. So theta, when using the arc sine function, will give me 36.9. To no surprise, if I use the arc cosine function, we end up with the same exact thing, 36.9. Similarly, if I try to find out what alpha is by using the arc sine function, we end up with 53.1. And our cosine function, same thing. But what is the one thing that's linking these the sine and cosine functions together that causes them to be identical? Well, it's the fact that theta and alpha are complements of one another. So what makes sine and cosine equal to one another, what makes them identical to one another, hence the word identity, right? What makes them identical to one another is the fact that the angle that we are finding the ratios of happens to be complementary. So sine of an angle and cosine of the complement of that angle will always be equivalent. This is important. I encourage you to take extra note of this, okay? Because this is the concept that was displayed in the past couple of minutes. Okay. The two angles must always be complementary in order for this to be an identity. All right, with that in mind, let's try to figure out what are all of these unknowns, okay? So let's go through the first line there. I have sine of 45 is equal to cosine of x. In order for these two to be identical with one another, x must equal to, you guessed it, 45 degrees. In order for these two to be identical to one another, what must y then equal to? Well, y must equal to 80 degrees, because y plus 10 is equal to 90, so therefore y is 80. What must z equal to in order for these to be identical to one another? Well, z plus 25 is equal to 90, therefore z must equal to 65. Upping the ante here, right? So, what must the value of x equal to in order for these two to be identical to one another? 3x minus 4 and 2x minus 6 must add up to 90, therefore. So therefore, combining like terms, 5x minus 10 is equal to 90, 5x is equal to 100, or x is equal to 20. And that's it.